So there were a couple things that were, as you're prepping for retakes, and I think a lot of you are probably going to do some retakes, there were a couple things I noticed that people were a little rusty on. Okay, so one of them was, how do we factor a sum or a difference of cubes? Like if I have something, what's the pattern for? Plus. Okay, good. And then if I wanted to do a difference of cubes? Good. Okay, we haven't done that in a little while, but that's a really important pattern that you're going to use that a lot, moving forward. So if you need to review those, go for it. Okay, here's another one. There's just an example of one of the possible problems you could have gotten on the test. What a lot of people did incorrectly on this one is, here was the mistake. Can you tell me what the mistake was? Cube, yeah. Right, so if a synthetic ball, the weight varies directly with the cube of its radius, what does that make our variation equation then? Y equals k times x, or whatever you want to call it. What do they call it? It's radius, so r. Not r, it's r cubed, right? And so you've got, when you're plugging in your values of weight and radius, you're plugging them into this equation. The radius is being cubed when you solve for k. A lot of people just didn't include that exponent. Okay, make sense? Okay. And then the other one was, I saw this a lot. People made this, either did this. Why don't you guys get rid of earbuds, please? I don't want to see any earbuds. Phones, I need phones up here. Quickly. People either did this wrong or they made it way too hard. A lot of people, not everybody, but a lot of people. What do we do when we're solving an equation that involves fractions, rational expressions? We clear the fractions, yeah. So even people that did this correctly, and I should have, I might look back at these. I mean, like if you're not doing it the best way, I might go back and subtract a couple points here and there. You got to do this the right way. A lot of people are getting a common denominator and treating these all as fractions. That's way harder, right? We don't do that. We want to just clear the fractions. This is exactly the same approach that we've taken. We started this like 8 or 9 months ago when we did problems. Remember problems like this where we had something like, let's say, x over 2 minus 2/3 equals 4. What'd you do? Yeah, you cleared the fractions, right? What did you do to clear the fractions? You multiplied by the LCD, exactly. So the LCD in this case is what? 6. So we distributed 6 through the whole thing, and what did that give us when I distributed here? 3x. Hey, what do you know? No denominator. Minus 4 equals. Okay, that's pretty easy, right? Then you have a very simple equation to solve. Okay, so we do the same thing here, right? You don't want to be turning these into fractions and getting common denominators and combining terms. Of all the stuff you did in this section, what was probably the hardest stuff to do?
Word problems.
I mean, okay, maybe word problems. I'll give you that. Aside from word problems. What was it? The fractions over fractions. Okay, I'd buy that too, but that's, okay, partly because typically you had to add and subtract fractions. Wasn't adding and subtracting fractions probably harder than anything else, right? I mean, multiplying and dividing, pretty easy, right? Because you just multiply straight across, or you flip and multiply straight across. Solving equations, I would argue, honestly, is easier than adding or subtracting fractions because you get to just cancel all those denominators, right? The part that was really tougher would have been if you had to add or subtract fractions Then you had to factor the denominators. You had to get common denominators, expand the tops, combine like terms, and then refactor. I mean, that's honest. If you really think about it, that's the hardest thing you do in this entire section, is just adding or subtracting expressions that have fractions. It really is. There's more work involved. There's more opportunities for mistakes. This is a little bit easier because you don't have to go through that whole process, right? So let's look at this then. How are we going to do this without having to do any of that difficult adding and subtracting fractions, getting like denominators, all that stuff? What do we do? Okay, yeah, so first of all, what is our LCD? We need to factor everything, don't we? Yeah, so let's do that. Okay, so we factor this first term, and we get 4 over plus 2x over x minus 2 plus 2 over x plus 2 equals 0. Oh, and by the way, okay, another thing I'll mention. I got a lot of stuff, don't I? So when you're solving equations, I understand why people do this, because they're just focused on the left side. But each step should be written as an equation, not an expression, right? Every time you make a step in algebra, you move down to the next line, it needs to be equivalent to the previous step. If it's an equation, this needs to be an equation. Because a lot of times what people did, and this, I get why, but when they got lazy and didn't write the equals 0, that prompted some mistakes. And it's a pretty easy one to fix. Just make sure you're always writing it as an equation. Okay, so we did this. Now the LCD, you were just telling me, is what? Okay, good. And how come? Because that's, how do we find an LCD? Good, we multiply all the different factors in the denominators. What if one of these, what if that had been squared? Okay, then we squared it in the LCD, right? We didn't have to deal with that here, but if one of the factors is raised to a higher power, then the LCD would inherit the highest power of the factor, right? Okay, give me 1 to 5 on that. Is that all ringing a bell? Is that all good? Okay. So then there's our LCD. We're just going to distribute that through the entire equation. What was it again? X minus 2. We distribute that through. And what happens here? What cancels? Everything, yeah. So we just get 4 plus what's going to cancel here? Okay, the x minus 2's cancel, so we get 2x times x plus 2. What's going to cancel here?
2 times x minus 2.
There you go, because the x plus 2's would cancel, right? Give me thumbs. We good on that? Okay. Equals 0. Good, and it's an equation. And now that's easy, right? That's a piece of cake. Yeah, we just distribute, so we get 4 plus. Okay, now what? Combine like terms. And this is a piece of cake now, right? 2x squared. Okay, equals 0. Okay. Okay, right. So we got to factor this, right? We're just solving polynomial equations. So this is an easy one to just factor and apply the zero product property. So this factors into, what do I factor out? Okay. Okay, good. So either 2x equals 0 or x plus 3 equals 0. So my solutions are -3 or, and a couple times people forgot the 0 there, right? That's a factor too. Okay, now we have to be careful though. What are our exclusions?
-2 and 2.
Yeah, look at this step right here where we've got everything factored in the denominator. X cannot equal -2 or 2. So we're safe, right? Those are both valid solutions. If one of those had coincided with an excluded value, could we use it? No. Make sense?
Yeah.
Okay, does that help a little bit? Okay? All right. I'm going to shut up, be done.